So welcome to the Manchester Table Demonstrator. This is a piece of kit that was built to communicate some of the challenges we face in our cities going forward. And this is the start point for the evolution of a tool that we hope will be of use to planning authorities. As you can see, we have a number of infographics here which describe the modes of transport that are moving through the city of Manchester, which will say this is a model-driven user interface. So the Saturn strategic model that underlies this user interface and drives the movement of traffic around the city. We have a DFT algorithm here which allows us to show the predicted rise and growth of residents in the city, pollutions, noise levels generated. And we also have a wheel here that allows us to play around with the innovation levels in the forms of transport that will be available. So as you can see, as innovation grows, the options and modes of transport grows. With no innovation, moving from 2010, 2020 and into 2030, there's very little growth. There's a small adoption of e-cars there. But innovation and integration is vitally important to the success of our ability to continue to use existing infrastructure but grow its capacity. And as you can see there, the various transport providers, the more they integrate, the more joined up things are. Ticketing and booking of payment systems are all one system, for example, but it's similar to the Oyster card in London, and the impact on the environment is great. So this is fantastic, but what about the people who live and move around the city? For this particular demonstrator, there's only four examples of civilians and how they move around the city. Our first example here is a recent student. She lives in a shared apartment on the eastern side of Manchester and works over here. And using the Saturn model, we are able to calculate the route that she's most likely to take. So in 2030, with loads of innovations, she's probably going to use an e-bike, and you can just about see the route that she could possibly take. And today, she uses a push bike, so small change in mode of transport, but same route, and innovation has very little impact on her route. So we look at 2020 for example, and go to set off on the journey. You'll simply, you can see the line moves down, and the routing is based on the algorithms and the strategic model, and of course the behaviours that this particular character exhibits. So you can see here her main motivation is minimal cost. I mean, actually today she pays nothing because the push bike's paid off. Again, in the future, time reduces with an e-bike, small amount of CO2, and costs her £1 for that journey. The interesting thing from a strategic point of view is what interventions might affect the way she behaves in her journey throughout the city. So, for example, if we introduce roadworks, well, actually, as a user of a bike, and they've got the ability to ride on pavements and cycle around the traffic, it's not going to really affect your journey. But introduce factors such as bad weather, and the model is now assuming that the bike is no longer an option, so what's the closest and cheapest alternative? As you can see, it's now costing her £3 as opposed to a pound, fraction less time to journey and a bit more CO2. And other factors that we can start to think about, and these pucks can be programmed to do anything, but in this particular instance we have some set parameters, some set options. We can see what other, increasing the frequency of trains, how does that affect her journey? And you can see the overall impact and the change over here. Another use case is a family who live on this western side of town, drop the child off at daycare, and then travel into the office. So in 2020, with moderate levels of innovation, they're probably going to use an e-car, drop the child off, and then they get into town, they're actually going to use an Uber-like style service where they can offer the spare seats in the car to other commuters, thereby reducing the cost of their journey and increasing capacity on the road, so less vehicles. So what other policies can influence their journey? So for example, a park and ride scheme, whereabouts, in what proximity to the daycare centre will they actually decide to park and take the bus? Will roadworks affect their behaviour? Something turn around and influence, if we actually get close enough to their house, they're going to use the bus for the entire journey, actually regardless of the park and ride. So this particular model has only got a couple of representatives of this populace. In the future, we hope that we can start to introduce into similar type of models a simulated population. So people and zones are set up for residential and industrial, commercial areas, and we can start to understand the impact of people living in a certain area with different types of lifestyles and how they will move around the city. I think that's probably a couple of years off, but in the immediate future, can we build a multi-layered version of this driven by models and different data that allow local authorities to very quickly interact with the models that they've created and so far have very little access and control over? What are the challenges associated with this, and who are the appropriate software developers that will push this type of concept through to reality? So I'm really looking forward to getting your feedback from the questionnaires you've been sent, and watch this space. Thank you.